was JPM Healthcare this week, which is a huge industry conference. The joke is that no one you know has ever attended JPM Healthcare, because JPM Healthcare is a invite-only meeting that is for bigwigs and people with, real money.
Yeah.
So there's a bunch of euphemisms for the conference ecosystem that is not actually JPM Healthcare. But a bunch of people do events at the same time as JPM Healthcare. And those were great.
Good.
So it was we did demo day with Colonel, which is this near infrared imaging helmet. Although they make dev kits, so you don't actually have to use the helmet. But that's their really interesting device to track blood oxygenation. So you can use it as kind of a less demanding MRI system. It only sees about a centimeter deep into the skull, so you can only kind of capture what's happening on the top of the head.
Yeah.
And so the two things. One, because of the helmet itself, it's like where the sensors are, you're really capturing only the top of the head. And then two, your depth is limited by the photon transport and how many of the very, very few photons go into the head and then come back out. But those are the ones that you detect.
Yeah.
So deeper is much, much less likely that the photons that go deep will come back out, or certainly come back out to where your sensors are. So it has some limitations in that regard. But you don't have to have a 2-ton super cooled magnet system. So it is kind of portable.
Yeah.
And then just another nice meeting on Thursday with companies talking to startup founders. One was a PhD from Stanford, from the lab that one of the co-founders from Neuralink, and the other a PhD from Oxford, and went through the same lab that I did, with Tim Barron's doing animal electrophysiology, although now she's doing a very consumer-facing company. Anyway, that was great too. Really nice. We now have, there's a bunch of UIUC students here.
Oh, yeah?
Yeah. So I'll meet up with them today. So they're all with Neurotech at UIUC.
Okay.
One is the kind of like partnerships manager.
Okay.
Excuse me. I think he's a senior, and I'll find out. He was definitely in earlier. I was supposed to meet him last night, but my daughter was sick and my wife had something, so I haven't seen him yet. But then there's two I think freshmen who are coming because Photonics West started, which is a big trade show for optical technology.
Right.
And then there's a sub meeting called BIOS, which is focused on biomedical optics.
All right. Yeah.
Or it's Biomedical Imaging Optics Society or something like that. I don't know. BIOS.
Yeah.
And so that I'll meet with them later today. We'll kind of walk the trade show and see, as well as like they'll come by Frontier Tower and look at it as like feel it out for the hackathon in April. But really excited because the UIC has such a big neurotech society or student group. They're helping coordinate a lot of the other student groups, as well as like I'm really encouraging all the student groups that are established to have an eye towards how to help the new groups get started, right? Like, like it'd be great to at least devote a bit of time to helping the new groups. I love that the UIUC is leading the way to have a Midwest Neurotechnology Conference, student run. But they've reaching out to like Purdue, Indiana, UIC, U Chicago, Northwestern, Wisconsin, Michigan.
Yeah.
You guys close to Michigan?
Yeah. Yeah.
I should know this.
Yeah.
Yeah. And let's see, what else? Just pointing out the other issues that students in other countries have that we don't have to deal with here is meeting with the students in Africa this morning, and they're in a blackout.
Oh, okay.
and unfortunately, it is much more common than it's not just a power outage. It's like one of a regular, like that's something that regularly happens. And I'm not sure everything about it, but it comes back to this issue of like how best to we teach this boot camp of MRI processing, but still a lot of the curriculum is assuming a kind of I don't know if this is a perfect example, but like that we're assuming a lot of weird prerequisites. weird being this acronym about
right.
The kinds of it's I don't know if that's exactly the acronym I'm trying to get at.
Yeah, the weird populations in psychology.
Yeah, that we're certainly not the majority of the
Right.
planet. and it's like I think I said last week, setting up a VNC server in Germany might actually be the single most useful thing that we could do for the students, because of connectivity issues.
Yeah.
Although I and then I'll finish so you can get started. But had an incredibly productive week following Better Code, Better Science.
Okay.
I think it says a lot about the project that the so this is not just a Russ Goldrack project, right?
Yeah.
So obviously he's writing the text, but he's doing it in an open source manner, right? I was looking at the GitHub repo and I was looking a little closer, and I see two other contributors, and so one is Stefan Bowman, who's
Okay.
the Nerddesk guy, and the other is Yarek Halchenko, who is the Nerd-Debian guy.
Okay.
And I like the fact that these are the two people that we've previously reached out to for the Active Inference Institute to speak about open source.
Yeah.
So I like that those are the two names associated with Better Code, Better Science GitHub repo.
Okay.
And then I think it's like let me just check this, but and then I think it's like I think Claude is another which again makes sense in this for this particular
Claude being the agent or the.
yeah
Okay.
yeah. It's so it looks like well, it's funny because it's like I see because I think he's talking about data lad, so it certainly makes sense that here we go. Sorry, I'm just okay. Well, I'll find it, but
Okay.
like that makes sense that they also have a coding agent be one of the contributors.
Yeah.
And I told you his postdoc is like a senior person at Anthropic, so
Yeah.
I think that explains his choice. I've been using Google's tools,
Right.
so Gemini, and had a really productive week coding with Gemini. I chose a project. I'm supposed to be on the microstructural MRI team at Camera, and most of my academic papers are on kind of diffusion processing or diffusion data.
Okay.
So it's not it's not out of my my area, but for the project direction I took, it's actually a really great. I refactored an existing INRIA project because I knew, JAX was designed as a NumPy replacement, right?
Mm-hmm.
And it's like JAX was very much designed as a drop-in replacement for NumPy, right? And so I chose something that I knew was built on NumPy, but was currently a slow CPU kind of implementation. And refactoring it, and then following a particular. There was a student back in Oxford who was one of these, like, you could tell that this was the brightest person in the room, kind of person.
Yeah.
And he did his PhD with Terry Lyons, who's like a famous mathematician, specifically on neural differential equations.
Okay.
Right? Like using neural networks to solve. Yeah. I don't know if it would be right. I forget what his thesis title is, but something like neural differential physics or something.
Really? Okay.
Yeah. And he's one of those people where almost like Francois Chalet, where you can see this is someone who's kind of like defining the software stack, for an area.
Mm-hmm.
Anyway, it's like it started as a Jack's refactoring of this microstructural MRI project, but I found that by actually following everything that Patrick Kidger, I think the choices that he's made, it's like, oh, now you see why he's done all these things. And it just turns out that his scientific software stack is actually very well designed for solving the problems in microstructural MRI, which is really cool. So I've got I've got a lot done on it. It's also a great example of just what Russ is getting at in terms of just like my benefit here is that I do know the area, and so it's just like, okay, at a certain point I can take a kind of known data set that lots of researchers have used, I can process it, and I kind of know what I should get because other tools have processed this data before. Maybe tools that are slow, but tools that have been well vetted, and so you get these answers out that tell you something about this particular data set. Now I can do it, but it takes 4 seconds on a laptop.
Yeah.
Right?
Yeah.
Because I'm just everything is super massively parallelized, and so it's very cool. I think I'll have like a nice little virtual MRI scanner out of it. and it's nice work that actually, when fully developed, will be really interesting, especially in the connection with like super high field MRI microscopy and histology, and the kind of work that people are doing there. So sometimes they're taking post-mortem brains, they leave them in the scanner for 24 hours. So and they just you get these like absolute incredible data sets that you can then use to test out techniques, as well as like it being super interesting to apply to very noisy data sets, and the kind of data sets that they're collecting in Africa, where they're maybe collecting with what we would consider an old scanner, but now we can basically ask the system to hallucinate. Tell me what this would look like if we collected it at 7 Tesla on a research scanner.
Yeah.
So it's, I think it's going to be an interesting project, and I'm getting to the point where I'm thinking about, reaching out to some of the MR physics people I know, seeing what would be a good, kind of real world test that would make them go wow. So,
Yeah.
sorry, I talked for a long time.
Oh, that's fine. Yeah, that's great stuff. Looks like there's a lot of stuff going on, and oftentimes, just don't get to touch base with all that's going on. So, yeah, this Better Code Better Science. This is a GitHub repo.
Oh yeah.
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 Okay.
I mean, Russ. He does every. He loves to do things in the open, right?
Yeah.
And he's if I had the if I didn't have the social anxiety, I'm sure I could have reached out to him as soon as he published it.
Yeah.
As soon as he said, and perhaps gotten involved. Like, it's the kind of thing where he's always hoping that more people will get involved. I'm gonna go to I'm gonna go to a meeting that's in the tower, but on AI assisted coding, and at least talk about this. I didn't want to forget what we talked about last week, but that some like I still don't think I'm using anti-gravity with which is Google's IDE as well as I could.
Right.
Again, to Russ's point, most scientists are self-trained programmers.
Right.
And so I, and I maybe had more training than most, because essentially my first job out of college was eventually taking over a software engineering team, being their manager. These guys knew, but my programmers were 20-year veterans in coding with IDEs and C++ application frameworks. They knew their tools.
Yeah.
Right? I didn't. I just knew the problem area. Right.
Right.
So I'm still missing things. Just talking to a professor up in Toronto, and he was just like, "Yeah, I've been using anti-gravity, and it's like having a team of grad students working for me." And I said, "Well, I'm using Gemini, I'm using Jules," and he didn't know what those were, but when I started using anti-gravity, I could see like it's essentially a GUI for Jules, right?
Right.
At the same time, there's definitely wild card characters. There's characters that you can use in your prompts that have special meaning, and I still don't know what those are.
Oh, yeah.
So I don't know what a slash is for workflows. I don't know what a mention is. So I'm going to go to this AI assisted coding where it's a bunch of basically like, web front end people.
Right.
And I'm going to see if I can get a better sense of what are these, a better professional sense of the tools. Because I'm sure I'm still using them in a very crude, self-taught way.
Yeah.
But the other thing being that as it relates to the open source sustainability project, like there's some Claude Code projects, like Gastown. I don't know if I'm gonna be able to find it. Let me see. Yeah, so let me just share,
okay.
Share this. Coming back to again what we were talking about. So I had we have a constant stream of visitors at the tower, right? Because it's like, we've got over 500 members in the tower, and then like there's plenty of space, so people are always coming by. And this was someone who's using AI assisted. I'm going to call it AI assisted. Never use the term vibe coding. Yeah. I'm still not sure. Yeah. But he was just like wanted to know if I was using it, but seemed to think that like I would benefit from having it do the data analysis for me, or like you can teach it how to use the tools you use. And I was like, what tools? I still, but HM Gastown, which reminded me a lot of, I think Sarah's projects, in terms of being, a multi-agent LLM. Software development team where everybody's got roles and things like that. And again, I don't know how I always come back to two things. Like one, what's your real vision for the open source sustainability in terms of like you're not trying to make a coding agent.
No.
Right? So how again do you define the goals of the project? It in a way that distinguishes it when so many of the implementations could be seen as like this is a software development project.
Right.
Sorry, that's more of a question.
Right. Oh, like what the vision is in terms of. Yeah. So I guess the difference, you're not developing a tool for doing the actual like helping people in projects. It's more like simulating a project itself and then looking at the sort of the possibility space of what could happen in that project. So, you could simulate a functional project, you could simulate a dysfunctional project, you could try different scenarios where, so I know that the work that Sarah did uh, a year and a half ago now. It was just generating some sort of, showing a proof of principle that this could be put together, and put together in a, not in a large tech company sense, like, where it's very polished and it's for purposes of, like, enterprise use. It's just kind of like building a simulation so that we can simulate, like contributors, and then how they put together issues and how they do these things. I mean, that being said, of course, how accurate is, say, like a large language model generated uh, system like that, in terms of replicating what people would do. That's not necessarily, a one-to-one thing. You're going to have sort of a. That's why I'm thinking, well, maybe we need to be a little bit messier in the sense of having human types of issues, or human types of things. Maybe, a large language model, for example, would generate very tightly defined issues, and they're very, self-contained, whereas like a human contributor might have a very open-ended issue, and it kind of gets worked on as it gets worked on, and it evolves into new things, and that sort of thing. So you don't have the same sort of efficiency imperative. You're just interested in seeing what that structure of the project looks like, trying to move forward from there and simulate some of those scenarios. Um, I mean, my experience with open source, at least, has been like it's much more open ended than like what you might see in a typical, where you generate a bunch of issues and you solve them efficiently, and that's interesting, and that shows that you can actually do that. But then beyond that, what are we actually trying to figure out? I mean, we're not using it to improve performance necessarily. We're using it to simulate how these things actually work. Um,
Yeah, yeah. No, that's good. Um, it's certainly, yeah. I see. Again, I've got an interesting perspective on it as a Fedora packager, because it's one thing to. I've been a software engineering manager, and I've also seen Fedora packaging,
yeah,
and at least peripherally on a lot of open source scientific software projects, and you know, a company has a very clear vision.
yeah,
It might change, but it's just like, we want these features. We want this thing to do this stuff so that we can charge money.
well, yeah, yeah,
And open source projects, people are coming along all the time with kind of their own goals and considerations, and some of them are potentially even at cross purposes, right? So
yeah,
this is why you get forks where, um, I mean, even well intended hard forks, where it's just like, hey, to implement this thing, I have to actually really modify the tool.
right, yeah,
So I can't actually let this be a kind of parallel process. This is a twig,
yeah,
off the, um, and it's like, I've certainly seen that too. I've got, well, um, I mean, you know me. I'm always going back to the AI economist, that particular project, in terms of just how, as a tool in which they had agents, but they were actually more interested in, um, the the um, the governing framework that the agents existed in. And so in this case, you know, it was like taxation, right? Or at least in the one of AI economists' examples, it's the taxation program, and you know, it was predicting basically how many people would cheat. But it was an interesting simulation where you show that, like, you show the trade-offs on that, and that, like, at the end of the day, a certain amount of tax cheating is allowed because the framework would actually become degenerate if you tried to maximize, you know, you tried to maximize zero crime. That you make it tolerable so that most people pay.
Yeah.
and that you don't need to spend so much on oversight or enforcement. I mean, it's that kind of, you know, and they were doing RL on the governing framework.
Yeah.
Even though, you know, it was a hierarchical RL problem where the agents were RL agents too.
Yeah.
But you I think you're interested in the the potential messiness of the problem. I mean, in the sense of like you want human-like agents,
right? Well, human-like in the best and worst sense, yes.
but and then what is the sustainable? What is the sustainable governing framework?
Right.
Or what is the framework that is the most encouraging sustainability or robustness, maybe longevity? I mean, you know, like, I know that the Software Sustainability Institute's work is not exactly the same thing, but it's certainly a very it's an understandable goal that, like, the work put into a particular software project, it has the potential for a life, a very long life, and a very fruitful one. You know, if the code is maintained and you know, cultivated.
Right.
You know, this goes back to the kind of, like, you know, like the original Richard Stallman arguments about how software artifacts are different than the kind of artifacts that society has produced before.
Yeah.
Right? Like, there's zero cost to copying them.
Right.
I mean, essentially zero cost to copying them. Right. So you can make a bazillion of them as easily as you know, that making that first one is the hard part.
Right. Copy 0 is more expensive than copy 1 and
right.
copy 2.
Yeah, and then you know, but then that it is this now, at least in an open source fashion, it is now a template, both for understanding a particular problem as well as, like, you know, a building block to something even bigger, perhaps. I mean, in the kind of Unix philosophy of pipes, where you can now, you know, string 10 tools together and actually create something new. Anyway, I'm sure you had some papers and some
Yeah, yeah.
agenda items.
Let me get some things up here. Some of the things you mentioned. Do you have links for the Better Science GitHub?
Oh yeah, absolutely.
And
I like the Mist book that they did. I think that's the new. Yeah, this is the current rendering of the book. Is there?
So let me pull up this one. So this one is the this is Gastown. So Gastown is
that's again just getting at Claude agents, like multi-agent code development.
okay. Yeah.
And just an example of using one of these commercial systems in a kind of sorrow way.
Yeah.
It just just it's fascinating to me that it's so similar.
Yeah.
But at the same time, there's a bunch of reasons why it's actually really useful for LLMs in their current form to adopt this, So actually, I believe Gemini, I believe the Google team actually refers to artifacts as text objects that LLMs create to give themselves short-term memory.
Okay. Wow. Yeah.
So they're and again, what I'm trying to do is to see how these big commercial teams, right, who are dealing with, the frontier models, right? How are their engineers trying to, deal with the limitations as well as extend their functionality, right?
Yeah.
So it's just like imagine you had all the resources in the world, because that's basically what these teams have. Right? This is what Google DeepMind's doing, right? It's like they're trying to get their agents, their thinking models, they're trying to get them to break up tasks as they go. They want them to stop, plan, write the plan, then restart, taking item one, now break that up into subtasks, right? Start doing those subtasks. Know when you've completed those subtasks, right? So there's a lot of breaking up a task, and there's a lot of again, let me make, I think the Google term is an artifact, and some of that is what if I get cut off at this point? What if the system I'm on crashes, which certainly happened to me developing yesterday. Starting agents on a DGX Spark is interesting because you've got 128 gigs of RAM, essentially, and so the system's agents kept on seeing my Blackwell processor and thinking that they had so much RAM that they were each grabbing 90 gigs, and then it crashed. Then the OS started having to kill things because it didn't have enough RAM.
Yeah.
But just so they're trying to move to multi-agent, but they need some intermediary output to so that they can share with each other. Hey. I'm just talking about some of my AI assisted coding.
Yeah.
So Gastown was one of the programmers who said that he like, everything he does these days is AI, is agent driven, and he suggested I look at Gastown. My problem is that I've kind of committed to, I don't have unlimited resources.
Right.
And I feel like I'm already paying Google enough.
Yeah.
But I'm super curious because there's definitely a lot of buzz and excitement around Claude Code.
Yeah.
I'm definitely trying to push having a tighter loop. I mean, it seems like some of like why you don't have agents at the terminal is actually AI safety, is somewhat AI safety driven.
Yeah.
And by that I don't mean like, Ghost in the Shell. I mean like so that an agent doesn't like erase your drive.
Right.
Yeah. It's not just to keep the genie in the bottle.
Right.
You don't send your life work to dev null. But then the second link is the Poldrack book.
And this is the book. Where is the GitHub repository?
Oh yeah, sure. So the GitHub.
If they have a link on that now.
Yeah, one sec.
All right. But yeah, this is the book. Yeah, so this is the sort of the back end or the front end of it, and then.
Like I see some more people down the bottom. Yeah, he just moved the repo to. Okay, here it is.
This is the read-only one. Yeah.
I got it.
Okay.
So he in the new year he moved it to. He moved it to become its own organization.
Oh, okay, yeah.
Instead of so his like his GitHub username is Poldrack.
Yeah.
But so it used to be a personal repo, and then he made it into an org.
Right. That's always a good strategy. Although you always have like stuff that's uncoordinated across the different. Yeah. So it looks like we have 5 contributors: Stefan Bowman, Claude, Yaroslav, and and Giorgio, I guess.
Yeah, Giorgio was the one I didn't. I don't know him.
Okay, yeah.
I'm assuming 100%, or I put money on that. That's a neuroimager.
Yeah. Okay. Yeah.
I'm gonna see. I could be wrong.
Yeah. And then Poldrack, of course. Yeah. So and this is the book. I guess this is just kind of the back end of the book, and Yeah, so that's the front end. What is Claude doing for this repo? I mean, is it just like to uh, specifically how is Claude committing to this repo? Do you know or?
No, I mean, it's. I don't think the book is primarily like trying to be. I think he's just trying to acknowledge that Claude is absolutely a part of his workflow.
Right.
And I mean, at this certainly for my diffusion microstructural. It's a crappy acronym, but diffusion microstructural imaging in Python. So DMI.
Yeah, DMIP.
Yeah. I absolutely hate it because I can't make it into a word.
A cool word, yeah.
Yeah. I in my head I just call it Dimpy.
Yeah.
but that's a flipping around that I don't know how to justify that. Like so much of it's not just the coding, right? But it's the conversation. It's like you have a conversation to get to the point of having agents code, right?
Yeah.
So I mean, I absolutely feel like I have to acknowledge this this model in like it's a co-author.
Yeah.
like it's a co-author, and yeah. And it's been interesting. I think last week I talked about the kind of low level GPU programming work that I'd done, and how incredibly useful it was for it to be this expert in in the kind of the low level details of memory systems, architectural differences, conda limitations, right? So, like, by the way, I mean, if anybody hasn't already, like, I've switched to UV for everything Python. like, um, I noticed that the Soffit team. So this is the Mind's Eye, um, the Mind's Eye 2 team. The former Stability AI guys that now have their own startup.
Yeah.
So that was where I first noticed that they were pushing their MedArc open science group was like first you install UV and it's pretty amazing, but again it's the kind of thing where it's just like I was working and NVIDIA was pushing Conda, and I think that's partly because Conda's got like it's got a big team too, right? So it's just like NVIDIA wanted to be like Anaconda's on our DGX.
Yeah.
The problem being that you have an ARM dependency, right? It's not an x86 platform.
Yeah.
Right? So there's stuff that doesn't work, and so when the DGX came out, there was the first thing they were saying was just like Anaconda saying like, hey, we're working hard to get the rest of our stuff ported, and so it was like it was kind of a good thing, but it was also like, hey, by the way, this isn't ready as a development system. Gemini, I was already using UV, and they were Gemini pointed out that that UV will solve all your problems on Earth.
Okay.
And it totally has, and it's faster. In every way, shape, and form, it's better. In terms of basically these automates. What would be 3 commands is kind of essentially one with UV, just immediate virtual environments for your systems. And I see this more too, where applications now, Python applications are, so it's like I can UVX something that would be a pip install, and basically run it both creates a virtual environment, pip installs the tool, and executes, right?
Yeah.
So what you see with UVX Nifty app is you see a GUI appear that's ready for work.
Yeah.
Right? But it's actually doing that in a sandbox, with the Python you need and the requirements that tool's going to need. Anyway, I'm getting very software engineering today.
Yeah.
But I've loved it. I mean, it's made me actually consider, at first I was just like, okay, we can just keep this box on the network and people can load jobs on it. With UV, I think it could actually be your workstation. It could be your PC.
Yeah.
For sure. and you should be doing everything in jacks.
Okay, yeah.
Yeah. Let me. I think I shared this with before, but if not, this is the guy at Oxford whose tools. He was at Oxford. It's funny because I think this guy's now in San Francisco.
Okay.
Like everybody.
Okay, Kidger.
Kidger, yeah. And if you go to software, right?
Yeah.
If you see these particular tools, right? And I definitely want to say that down to SymPy to JAX. These are all best of breed implementations. Right?
Okay. Yeah.
I mean, it's the closest thing to kind of following core Julia people, and let me just also find his this is it is doctoral, so if you see in publications, neural differential equations and machine learning, this is thesis. On neural differential equations. But he was he's the student of Terry Lyons, who's the guy who developed rough path theory.
Okay.
Anyway, really great software implementation to follow. And I tell you, I've talked before about Crunch Lab. So this is the crunch group at Brown. But like in particular, the times in which, you know, adding physics changes the problem in a variety of ways, right? There's a bunch of ways that which physics informed neural networks can be applied, and in diffusion MRI, in focused ultrasound, these are super valuable.
Yeah.
So I want to make the, you know, like the, I don't know if it's like the add-on book, but the response to Voldrac should be better code, better education.
Yeah. Yeah, that's yeah.
It's I get why he has the ordering he has, right?
Yeah.
But I'm looking at it partly. I mean, I was saying this to V before. We talked just after New Year's, and you know, in working with student groups, right? Like so one, it was crazy that I had never used an LLM, right? Like you know, I almost finished 2025. I've never used an LLM. Two, you know, somebody like Russ comes along, like again, you know, and he's been teaching. You know, he's such an educator, right? In coding in particular, right? And he's talking about it, right? But how about going the other way? Like, how can we use this to actually help students learn these concepts? You know, and anyway, so that's what I would like to see.
Yeah. Well, this is all great stuff. So yeah, why don't we move? I want to talk about Sakana, actually. So we'll move on to that. I have some things that I want to present on it, but then we can talk about it after.